In match problem 3, we want to do more or less the same thing we did in match problem 2. The only difference is going to be how we go about finding our critical values. So we still want to start off by finding the derivative of our given function. In this case, we have a composite function. We've got 1 plus x being raised to the 1/3 power. So the derivative of this function will be 1/3 times that interior function 1 plus x raised to the negative 2/3 power, and then times the derivative of that interior function. So the derivative of 1 plus x is just going to be 1, which gives us 1/3, 1 plus x to the negative 2/3. Now this is a perfectly acceptable answer for the derivative of our function, but there is a problem with the way this is being written, in the sense that it's hiding the potential critical values or misleading us as to what the potential critical values might be. So what we actually want to do in this case is rewrite this as 1 over 3 times the quantity 1 plus x to the 2/3. So in this case, we do want to rewrite this with positive exponents, because what that's going to show us is that this function will never be equal to 0. Because we have a 1 in the numerator, there are no variables, so there's no way for the numerator to be equal to 0. The function can't be equal to 0. But we can get a 0 in the denominator. So what we do is look at when just this expression in the denominator can be equal to 0, and that'll tell us when our derivative is undefined, or when it does not exist. So in this case, it will fail to exist whenever 1 plus x equals 0, which means our derivative will be undefined whenever x equals negative 1. So in this case, this is our critical value. So at negative 1, our derivative function is undefined. Again, I'm just going to use that x or some other notation there to distinguish between where we have a 0, meaning a horizontal tangent line, and where our function's undefined. So we can choose test points on either side of that critical value and evaluate the derivative at negative 2, which in this case will give us 1/3, and also evaluate our derivative at 0, which in this case will also give us positive 1/3, which means our derivative is positive and our function is increasing. So now what we have is a function that's increasing. We hit a critical value and it continues to increase. What's important to note here, though, is that even though the derivative is undefined at negative 1, we can plug negative 1 into the original function, because 1 minus 1 is just going to give us 0, which raised to the 1/3 power is 0. So since the original function is defined at negative 1, we can say that our function is increasing on negative infinity to infinity. Again, because even though the derivative is undefined here, the original function is defined at that point. So we won't have any breaks or open circles, asymptotes at that point.